So you just started keto and your cholesterol is off the charts. What do you do? Okay. There's a couple important things you need to know. Number one, and this was in 2018, the new guidelines by the American Heart Association, okay? This is brand new. They said total cholesterol is not significantly associated with heart disease. Okay? That's the new finding. They just found out. Looking at your total cholesterol doesn't really give you a lot of information in relationship to predicting heart disease. Okay? That's number one. Number two, your body makes 75%. 25% comes from diet. Why do we need cholesterol? Why does your body make it? To make hormones, sex hormones, cell membranes, bile to help you digest fat, and vitamin D, which is very, very crucial. And this is why when people take cholesterol drugs that block cholesterol, as in statins, they have a lot of side effects relating to these right here, which we're not going to get into. Now, what I did is I took my wife Karen's report, okay, that I'm going to show you. I'm going to walk you through this. This is an actual report done 11/15/2019. And we checked the total cholesterol, the LDL, the HDL, triglycerides, and we checked several other things because I always recommend when you get a cholesterol test, you get an advanced lipid profile. An advanced test that measures the two different types of LDL, okay, which we're going to cover. Now, check this out. This is what we found. Her total cholesterol was 261. Normal is below 200. So this is too high, right? So immediately you're probably going to freak out unless you understand that this total cholesterol is not the cholesterol that's floating through your arteries. It can't. It doesn't mix well with blood. It has to be packaged in a protein. So the total cholesterol is really all these other things combined, okay? So we have LDL, which is low density lipoproteins, because you need a protein kind of a sac to push it through the blood. Then we have high density lipoprotein, okay? So really, take the cholesterol and just put it to the side right now. All right, so we know the cholesterol is high. We also know her LDL. Look at that, it should be below 100. It's 195. It's more than double where it should be. The HDL should be greater than 50 because you want that higher because that's the cholesterol coming from the cells back onto the liver, okay? It's not the LDL from the liver to the cells. It's coming back the other way. Hers was really good, 71. Triglycerides, less than 100. Hers were 66. So this is where it's coming from right here. But thank goodness we did a test that goes a little bit deeper, and we measured two types of LDL. One is the large buoyant type of LDL, which is kind of large and fluffy as it goes through the artery. And number two, we measured the small dense LDL particles, okay? So I want to focus on this one right here, small dense. So the way it's worded on the cholesterol test is this right here, SDLDL-C, standing for small density. All right, here we go. Here's Karen's report. We have her name, we have the date, and we have the total cholesterol, which is 261, right? Check that out right there. And the second one that's high, LDL-C, that stands for LDL cholesterol, it's 195, okay? If we take a look on the second page, right here, look at this. The LDL is 2,128, right? But let's narrow in on this one type of LDL, SDLDL-C. That's the small dense, low density lipoprotein. This is the one that's dangerous, and it's actually 26 within the normal range. It's optimal. So guess what this means? It means that Karen's high level of LDL is not the small dense type. It is the large buoyant type. And it's the small dense type that creates the damage. It's one of the better markers for predicting heart problems. It's one of the best indicators for detecting inflammation deep inside of the arteries. All right, so let me just explain the inside of the arteries. So I got this really good analogy from a Dr. Sanjay Gupta on one of his YouTube videos using a frying pan, right? So it's a really great example of what happens on the inside of your arteries. So here we have this non-stick frying pan, okay? So you fry something on here, you put some fat on there, and it doesn't stick, right? And you rub it or you scratch this and you get rid of this layer, the fat will start to stick. Here's what you need to know. Cholesterol is not going to affect the inside of the arteries unless there's first some type of lesion, some type of erosion on the inside of the arteries, where the small dense type LDL can then penetrate because they're small and start developing plaquing. So the question is, why did Karen have such high cholesterol and such high LDL? And also, why did she have more of the large buoyant type versus the small dense type? And that's simply because of this. This comes from a high carb diet. It comes from consuming the wrong types of foods. When you're doing a healthy version of keto, where you're doing higher fats, lower carb, moderate protein, guess what? You're going to get into ketosis. You're going to start burning fat. And a fat cell is composed of mostly triglycerides and cholesterol. So that cholesterol has to come out. It has to be mobilized. So you can have certain times or transitional periods where your cholesterol goes up and it goes down. But as long as you keep your carbs low, you're going to get more of this type of cholesterol. And this is why I always recommend doing an advanced lipid profile, not just your regular test that doesn't tell you very much information. And so getting back to the arteries, there's various things that cause inflammation, in addition to the glucose and the sugar, which is a kind of a, most people know that. Seed oils, a lot of corn oil, canola, soy, cottonseed oil, and so many different foods, mayonnaise, salad dressings, going out to dinner, eating fried foods, very inflammatory. Smoking creates inflammation. Junk food creates inflammation. And also, when you're deficient in vitamin E, and you become deficient in vitamin E when you start consuming refined flour products, and that would be in the form of breads and pastas, cereal, crackers, biscuits, things like that, you start becoming depleted of vitamin E, which is the protective antioxidant to protect the inside of the arteries. And by the way, if you have any problems with the inside of your artery, the best vitamin E to take is not tocopherols, it's tocotrienols, okay? That's the one that you would want to help protect the inside of that layer. So now let's take a look inside the artery and get a visual of what can happen. So we're looking here at the inside of an artery. This tiny layer on the inside of the artery is called the endothelium. And this layer controls the tone of your blood vessel. It can increase the blood pressure, it can decrease the blood pressure, it can make the artery thicker or more elastic, but it's very sensitive to sugar, especially chronic sugar. I'm talking about chronic glucose. An average person in America consumes between 250 to 350 grams of glucose. That is at least 13 to 15 times what is normal. So when you expose the inside of your artery to that much glucose, what's going to happen? We're going to get this oxidation effect. It's like rusting out the inside of your arteries. Now, what happens next is the body's response to an injury. We're going to get inflammation. We're going to get calcium that's going to come in there and start building up and start to act as a Band-Aid. We're also going to get cholesterol that actually mixes in there and acts as a Band-Aid. We're also going to get fibrous tissue that's going to act as a Band-Aid. Altogether, this Band-Aid that's created from calcium, protein, and cholesterol is going to start to form a clot. And as that artery becomes more obstructed, the blood flow backs up and you start getting a diminished flow of blood. So what does blood do? It carries oxygen and nutrition. So now we not only starve off oxygen to the tissues, we starve off nutrition. And if that blood vessel turns into a capillary and ends up in the bottom of your feet, you'll get peripheral neuropathy, numbness, burning, tingling. If that artery is the coronary artery that goes to your heart muscle will start to cramp. as in angina, and eventually a heart attack. If that clot breaks off, goes up to your brain, and starts shutting off oxygen into your brain, you get a stroke. And so all of this can be completely prevented just by getting the sugar out of the diet. So if you're enjoying this content, go ahead and share it with someone that could really benefit from it.
So we got a ton of requests from a lot of you guys to comment on this video. Dr. Eric Berg goes over his wife's blood work. I don't know why, out of all the internet content and videos, this one in particular was deemed confusing or intriguing by so many people. I guess we'll find out. Quick note before we start, and if you're a regular viewer of the channel, you probably already know this, we're going to focus only on the substance. No ad hominems. I didn't Google him, I don't know anything about him. I didn't go watch a bunch of his other videos for context, nothing. Because it doesn't matter. The only thing that matters is whether the claims match the evidence. All right, let's go.
This was in 2018, the new guidelines by the American Heart Association, okay? This is brand new. They said total cholesterol is not significantly associated with heart disease, okay? That's the new finding. They just found out. Looking at your total cholesterol doesn't really give you a lot of information in relationship to predicting heart disease.
I don't know what he's talking about. Total cholesterol is not the best marker. It's a dirty marker, but it definitely associates with cardiovascular disease, with heart disease. I don't remember any American Heart Association guidelines saying that it just doesn't associate, period. Here's the 2018 American Heart Association guidelines. Like he said, population studies suggest optimal total cholesterol levels are about 150. Populations with cholesterol in this range manifest low rates of atherosclerotic cardiovascular disease. Nobody's saying it's the best marker, but this is the opposite of what he's saying. I've read these guidelines. There's nothing in there about total cholesterol not associating, period. Maybe he saw something else and misunderstood it. Is there anything in the description that he links as a reference? Okay, 2 links to journals. That's good. American Heart Association journal. That's probably it. Let's click here. All right. Sweet. Wait, this is scientific advisory for dietary cholesterol. No way. No way. Don't tell me this guy's confused. Wow. Wow. Yep. Here's the passage he's referring to. Oh my God. Generally, no significant association with cardiovascular disease risk. But this document is the science advisory on dietary cholesterol. I think most people understand the difference, but just in case, dietary cholesterol is the cholesterol content of your food. If you eat eggs or some butter, there's going to be some cholesterol in there. Serum cholesterol is the level of cholesterol in your blood. When you go to the doctor, when you get some blood work, that's your serum cholesterol levels. They're 2 different things. You could have high blood cholesterol levels and not eat any cholesterol. It's possible. It's like saying there's potassium in foods, and then there's my blood potassium levels that I see in my blood work with the reference ranges. They're 2 very different things. He's talking about serum cholesterol. Total cholesterol refers to the total amount of cholesterol in your blood, in your serum. He has the levels right there on the board, right? Levels of serum cholesterol. And the video is called Dr. Berg's Wife Has Crazy High Cholesterol. That's referring to her serum cholesterol levels. So he's talking about blood cholesterol levels, but the thing he just mentioned with the American Heart Association and the document he linked is on dietary cholesterol. It says right there, and in the title. It's the first word of the title of the paper he linked. Okay, so I just went over the document to make sure I didn't miss anything, because it's honestly a bit hard to believe, but yeah, he just confused the 2. He probably heard something vague about cholesterol and he conflated it with serum cholesterol. Either he's not super clear on the difference or he didn't pay attention to this reference that he linked. So total cholesterol, serum cholesterol, all right, it does associate with cardiovascular disease risk, but there are better markers. LDL cholesterol is better. Non-HDL cholesterol is even better. That's non-HDL cholesterol, not HDL cholesterol, all right? And many other things associate, but the best marker, causal marker, is ApoB. And we've made entire videos about it, and I'll link it at the end. Now, dietary cholesterol associates with cardiovascular disease risk in some studies, but not others, because it depends on a number of factors. But that's not even what he's referring to. The whole thing's a misunderstanding. So I guess let's just move on. I don't know what to expect now. Honestly, this is a stunning start. I'm a little speechless.
Her total cholesterol was 261. Normal is below 200. So this is too high, right?
Yeah, see, he's talking about serum cholesterol all the way. The whole dietary cholesterol was a complete sidetrack. I still can't believe it. Nobody checked this video before he went out. Nobody checked the reference.
This total cholesterol is not the cholesterol that's floating through your arteries. It can't. It doesn't mix well with blood. It has to be packaged in a protein.
Okay, this is all good stuff. Lipids travel in lipoproteins because they're hydrophobic, right? In an aqueous medium like plasma, they would clump up, so they need that protein shell to be transported. And it's very important, it's very good to shift the conversation about cardiovascular disease to lipoproteins. Why? Because the public discourse around heart disease always focuses on lipids, cholesterol and good cholesterol and bad cholesterol. But at the end of the day, it's high lipoproteins that raise cardiovascular risk. So lipoproteins are the vehicle and cholesterol is the passenger traveling inside that vehicle. And it's the number of vehicles on the road that causes traffic jams. And we said a minute ago that ApoB is the best metric. This is exactly why. ApoB is a direct measurement of the number of vehicles. Everything else, the lipids, the total cholesterol, LDL cholesterol, those are measurements of the passengers. So they can give you a rough indirect guesstimate of the number of vehicles, but they're not as good. ApoB measures directly the number of vehicles, and that's why it's the best causal marker of risk. Make sense? All right, moving on. This is looking up. This is getting better. Let's go.
All right, we have her name, we have the date, and we have the total cholesterol, which is 261, right? Check that out right there. And the second one that's high, LDL-C, that stands for LDL cholesterol, it's 195, okay? If we take a look on the second page, right here, look at this. The LDL is 2,128, right? But let's narrow in on this one type of LDL, SD-LDL-C. That's the small, dense, low-density lipoprotein. This is the one that's dangerous, and it's actually 26 within the normal range. It's optimal. So guess what this means? It means that Karen's high level of LDL is not the small, dense type. It is the large, buoyant type. And it's the small, dense type that creates the damage.
Yeah, I was hoping he wouldn't fall for this one. I hear this a lot. Small dense LDL is harmful, but large LDL is fine, it's benign. So my sky-high cholesterol is totally fine as long as my particles are large. Very common idea on social media. So it is true that if we look at two populations with the same level of LDL cholesterol, the one with the smaller particles will tend to have higher risk. But, and you may already be picking up on the problem here, and if not, let me give you an analogy before I give away the answer. Imagine two roads. Same size, same everything, and same number of people traveling in vehicles on each road. But road A has more traffic jams, so we want to figure out why. So we run this study and we find smaller vehicles run on road A, more compact cars, whereas road B has more vans and buses. So now someone pops up and says, aha, so smaller vehicles cause traffic jams. What's wrong with that logic? There's one key parameter we're leaving out. Pause the video if you want to think through it. It's the number of vehicles, right? If we have the same number of passengers traveling in smaller vehicles, we probably have more vehicles on the road. So we have two variables, the size of the vehicles and the number of the vehicles. It's precisely the same thing with heart disease. For the same level of cholesterol, people who have smaller vehicles, smaller lipoproteins, tend to have more of them to carry that same amount of cholesterol, right? So we have two potential suspects present at the crime scene at the same time. So who done it? Who's the murderer? Particle size could be the cause of risk, like he's concluding, or it could be an innocent bystander. These authors explain exactly this conundrum. At a given level of LDL cholesterol, individuals with predominantly small LDL particles, that's called pattern B, have higher risk. So people with smaller particles have higher risk. The seemingly reasonable conclusion would be that size matters and that clinical assessment would benefit from measuring both LDL quantity and particle size. That's precisely the logic we just heard Dr. Berg laying out. However, there is a flaw in this reasoning. At the same level of LDL cholesterol, the pattern B individuals, that's the ones with smaller particles, also have more particles. Is the risk attributable to the fact that they have more particles or to the smaller size? So how do we solve this mystery? Well, one thing we can do is run some statistical analysis to find out which of the two parameters tracks best with risk. Which one is the best predictor? Particle size or particle number? This is like running a large population study and finding that people who own ashtrays are more likely to have lung cancer. But of course, smokers are also more likely to have lung cancer. So we can do a statistical test to see which of the two parameters tracks best with risk. And we'll probably find it's smoking. Ashtray ownership will generally correlate with lung cancer, but not as tightly, not as closely, not as accurately, because some people might own ashtrays but not be smokers, and it's for the visitors or whatever. And some smokers might not have any ashtrays at the house, or they might smoke outside. So smoking will track much closer with risk. We'll find that it's a better predictor, and we'll probably conclude that ashtray ownership is likely a correlate, something that correlates, but probably not causal, probably an innocent bystander. It's the same thing with cardiovascular disease, and this type of analysis has been done many times with LDL. So the authors explain, collectively, the results of multivariate analyses, that's what the statistical technique is called, of numerous clinical trials provide persuasive evidence that it is the number of LDL particles, not LDL size or the amount of cholesterol, that is the principal determinant of coronary heart disease risk. So it's not about the size of your particle, it's how you use it. These scientists also explain it really well. Association of LDL size with risk typically loses significance when adjusted for particle number or concentration, same thing, like ApoB. So ApoB measures particle number, as we said, and particle size will generally correlate with risk, but after you remove ApoB, after you remove particle number from the equation, particle size no longer predicts risk. It's just like the ashtray analogy. And they add two more lines of evidence. Statins, which have a well-established effect of lowering risk, preferentially reduce large LDL. And number two, patients with familial hypercholesterolemia, which is a disease where people have very high cholesterol and very high risk of heart disease, they have mainly large LDLs, and they are at high risk, indicating that large LDLs are not benign. Here's a visual that really helps put all of this in perspective. Small dense LDLs are roughly 20 nanometer in diameter. 1 nanometer is 1,000,000 times smaller than a millimeter. Now, large LDLs are a little larger. Duh, right? A little over 20 nanometer. But then in the same family of lipoproteins, we have IDLs. So LDLs stand for low density lipoprotein, and IDLs for intermediate density lipoprotein. And IDLs also carry ApoB, this protein that identifies all of these particles that cause plaque and heart disease. And the diameter of IDLs is in the mid-20s. Then in the same family, we have VLDLs, very low density lipoproteins. But there are many sizes of VLDLs, many different models. The small ones are sometimes called VLDL remnants because they're what's left of the larger ones. VLDLs can go up to 60 nanometer, which is already 3 times larger than LDLs, and they can be even larger, over 70 nanometer. And all of these are ApoB lipoproteins. Now here's the kicker. There's a threshold. Lipoproteins that are too big can't get into the artery wall and can't contribute to plaque and heart disease. And that threshold is 70 nanometer. All ApoB lipoproteins less than 70 nanometer in diameter, including VLDL remnants and LDLs, freely flux across the endothelial barrier, that's the lining of the artery wall, where they can become retained. So the key threshold is all the way over here. The largest VLDLs are too big to get in, and they're not atherogenic, they don't cause atherosclerosis. Everything else is atherogenic. So in the grand scheme of things, LDLs are dwarfs. The difference between small and large LDLs is relatively minor. They can both get into the artery wall and contribute to plaque, as can much larger particles that carry ApoB. And this gets even more mind-blowing because all of these under 70 nanometer are thought to be equally atherogenic. Particle for particle, they all represent the same risk of heart disease. They've shown this with genetic experiments. So we all carry different genetic variants. That's why we're all a little bit different. Some are taller, some have green eyes, some have larger feet. And just like our genes can influence those traits, they can also influence our lipoproteins. So they looked at gene variants affecting LDL particles and other gene variants affecting VLDL particles. And the results suggested that all ApoB containing lipoprotein particles, including VLDLs and their remnants, as well as LDLs, have approximately the same effect on risk of cardiovascular disease per particle. Alan Snyderman breaks it down here. It was demonstrated that the decrease in risk per VLDL particle decrease was the same as the decrease in risk per LDL particle decrease. The conclusion that follows is that a VLDL and an LDL pose equal cardiovascular risk. Now, it's important to point out these genetic studies are considered a causal test, a more reliable test of cause and effect, because the correlations we looked at earlier, that experimental approach has some caveats that the genetics improve upon. So all ApoB particles under 70 nanometer are harmful, even VLDLs, which are way larger than the largest LDLs. So we want to keep all of these lipoproteins in the healthy range, not just some of them and let the other ones go off the charts. That's the misconception. Okay, one last citation to drive this home and then we'll move on, because these authors summarize everything we talked about so far. The large cholesterol-rich LDL is the predominant type in familial hypercholesterolemia, as we saw earlier. And it is firmly established that this LDL is responsible for their premature atherosclerosis. So, large and small LDL are both atherogenic, and it's not possible to judge which, if any, is more harmful overall. So, particle number determines risk. Particle size is probably just a correlate, kind of like the ashtrays in lung cancer. So saying that my ApoB is very high, but I'm fine because my LDLs are not small dense, is like saying that I smoke like a chimney, but I'm totally fine because I got rid of all the ashtrays. It's overvaluing a correlation that is likely not causal, while undervaluing the likely real causal factor. It's a huge mistake. So the important parameters here in the blood work that he shows are LDLP, he mentions it in passing, and ApoB, which I don't think he even mentioned. And those two are almost interchangeable. They're both measures of particle number, and they're both very high in her case. That is the focus to lower risk. And we can lower our ApoB with medications or with lifestyle. I'll link a video at the end with all the information on this. I'm sorry if this video turns out to be a bit repetitive, but this isn't the simplest topic in the world, which is why we have rampant misunderstandings, and I don't blame people. So I'm trying to make this as simple as possible. But you give me feedback below if we succeeded or if it's still super confusing. I tried. Now, what I usually tell people who ask me about particle size is it's probably not going to change anything, but if you, for some reason, are bent on having large particles and you have a way to do it, I don't see a problem as long as it's not at the expense of particle number, right? As long as your total particle number, your ApoB, stays constant or comes down, playing with particle size, I don't see an issue. All right, moving on.
Because I always recommend when you get a cholesterol test, you get an advanced lipid profile. An advanced test that measures the two different types of LDL.
Yeah, it's the second time he said that, but the reason these aren't routinely done when you go to the doctor is that they usually don't add that much useful information. Because the different size LDLs are all problematic, knowing if my LDLs are a bit larger or a bit smaller doesn't really change course of action. We still want to keep the total number of ApoB lipoproteins in the healthy range. It's explained here. The burden of proof for any newly proposed risk factor is that it must add to risk assessment by current measurements, or it must be more economical. LDL subtyping, which is looking at the different LDL sizes, does not meet either of these expectations. And LDL subclass measurement does not add independent information to that conferred by LDL concentration, so number of particles, ApoB, along with the other standard risk factors, things like diabetes, smoking, blood pressure, family history. So if you want to get these advanced tests and you don't mind spending the extra money, I don't think it hurts. Just don't let all those numbers distract you from what really matters, and that's ApoB. Now, many people don't know their ApoB, and your LDL cholesterol and your non-HDL cholesterol give you a rough estimate, but in a percentage of the population, they can be off. So when in doubt, get your ApoB. All right, moving on.
The small dense type, it's one of the better markers for predicting heart problems. It's one of the best indicators for detecting inflammation.
Yeah, this is an interesting point. It's an important point. Small dense LDLs are markers for a number of issues. They associate with diabetes, with insulin resistance, with obesity. So no wonder they associate well with heart disease. They're a marker for all kinds of metabolic issues. As some people say, particle size is a marker, not a maker. But none of these associations mean that larger LDLs are benign. This is why we have to be very careful with correlations and not assume causality. That's the trap he's falling into. Correlations can indicate causality or not. They can be a wild goose chase. So we have to dig deeper with the analyses, with the genetics, with the clinical trials, right? We have to go above and beyond. By themselves, the associations are very slippery terrain. All right, moving on.
Is the inside of your artery to that much glucose.
Wow, that's a really cool animation. Looks like he's inside the vessel.
That clot breaks off, goes up to your brain, and starts shutting off oxygen into your brain, you get a stroke. And so all of this can be completely prevented just by getting the sugar out of the diet.
Sure, excess refined sugar is a risk factor for cardiovascular disease, but that's an oversimplification. Getting sugar out of the diet can make things better or not. It depends what you replace it with. In fact, this exact question has been investigated and we've known the answer for a number of years now. Replacing refined carbs, so that's table sugar, candy, white bread, cookies, pizza, etc. Replacing that with unrefined carbohydrate from whole grains is associated with lower cardiovascular risk. Whole grains would be oats, brown rice, whole wheat bread, etc. Now, replacing refined carbs with unsaturated fats also lowered risk, especially polyunsaturated. Monounsaturated tended to be lower but was not statistically significant. Unsaturated fats would be things like nuts and seeds, most vegetable oils, and fatty fish. And replacing refined carbohydrates with saturated fat, so fatty meats, butter, coconut oil, etc., was not significantly different. And these findings are corroborated by other data from clinical trials, for example. So moderating refined sugars, added sugars, absolutely. Everybody agrees with that. But we should emphasize, try to replace them with something more health promoting so you actually get that upgrade, like whole grains or sources of unsaturated fat. That's not to say that a healthy diet can't contain some red meat or some butter. It can, but it's about the proportions. If you take the bulk of refined carbohydrates and you replace that calorie for calorie with saturated fat, it's a lateral move. You're not going to get an improvement. The key realization here is that cardiovascular disease is a multifactorial condition, just like most chronic diseases of the Western world. Multiple factors affect it. It's not all one thing. Every time you hear heart disease is all about this one thing, get your guard up. ApoB is a major factor, but blood pressure matters, diabetes, not smoking, inflammation matters, exercise, healthy body weight, right? They're all factors, they're all pieces of the puzzle.
Hey, before you go real quick.
Okay, that's pretty much it. So you see why in our videos we never go after the individual. First of all, it's completely inappropriate. Second, it's a distraction. It distracts you from the things that really matter. But also, here's a super likable guy, charming guy, right? Good delivery, calm. It almost felt soothing to watch him. He's got a very good calming quality. Unfortunately, most of the ideas have very little scientific substance because the bulk of the evidence is stacked in exactly the opposite direction. And these aren't new ideas. I hear this stuff on the internet all the time. And my guess is he's exposed to these online and he kind of cobbled this together. But he didn't really bother to properly fact check things. I mean, it's obvious from the way he started the video, right? With just a colossal misunderstanding of the fundamentals. It was his opener. That's what he planned to start the video with. And he didn't even read the thing he linked. So this is a very clear example that we can't rely on how friendly or how trustworthy or how genuine someone seems. It hinges 100% on the evidence. Not the packaging, not the presentation, not the messenger. There's just no way around that. This also confirms my general impression that I've always had. I have a lot of colleagues who are very frustrated and they say, all this misinformation on the internet, people just lying to the public. I never thought that explanation was convincing. I think it's much more likely that people are repeating things that they do believe in. And I think that's clearly the case here. I mean, he's talking about his own wife's health. Of course he wants her to be safe and healthy. I don't question that. So I think it's very obvious that he believes this. The problem is he's getting these ideas from unreliable sources and then uncritically accepting them. Dr. Berg, if you're watching this one day, you never know. A few months ago, you guys asked us to comment on one of the videos from What I've Learned, and that was a massive channel, had like 1 million subscribers. And within the same day, within an hour of the video being released, the creator hit me up on social media. He says he sometimes watches our videos. So you never know. And if somebody's in touch with Dr. Berg, hit him up. So Dr. Berg, if you're watching, what will lower your wife's risk is lowering that LDLP and ApoB. The particle size is mostly a distraction. Now, a good specialist, cardiologist, or lipidologist will probably check her for familial hypercholesterolemia because her numbers are pretty high. Depends also if they just got high or if they've always been high. And they might also check her for some other lipid disorders. But in most regular people that don't have an underlying genetic condition, ApoB can be lowered very quickly, almost overnight. It can be done with meds or it can be done with lifestyle. And we've actually made a whole video showing exactly how to do this, all based on peer-reviewed literature, and you can check that out right here. And here's more on ApoB and what each number on your blood work means. Take care. See you next week.
So there was a Dr. Gil Carvalho who did a fact-checking video on me. So today we're going to do a fact-checking video on the fact checker.
So we got a ton of requests from a lot of you guys to comment on this video.
Okay, so the first thing he says is there's a ton of you that requested to do a video on one of my videos. What does my channel have to do with your channel? I'm just curious, like, Gil, can you just maybe show us how many people actually requested this video?
We're going to focus only on the substance. No ad hominems. I didn't Google him. I don't know anything about him. I didn't go watch a bunch of his other videos for context. Nothing. Because it doesn't matter. The only thing that matters is whether the claims match the evidence.
So don't you hate that when you know that there's some bad news coming or some negative things about you coming, but they kind of prep it with, oh, we won't look at it as a character. We'll be really nice to him, as someone maybe pushes you underneath the bus. Okay, let's continue.
Let's go.
This was in 2018, the new guidelines by the American Heart Association, okay? This is brand new. They said total cholesterol is not significantly associated with heart disease. Okay, that's the new finding. They just found out. Looking at your total cholesterol doesn't really give you a lot of information in relationship to predicting heart disease.
I don't know what he's talking about. Total cholesterol is not the best marker. It's a dirty marker, but it definitely associates with cardiovascular disease, with heart disease. I don't remember any American Heart Association guidelines saying that it just doesn't associate, period. Here's the 2018 American Heart Association guidelines. Like he said, population studies suggest optimal total cholesterol levels are about 150. Populations with cholesterol in this range manifest low rates of atherosclerotic cardiovascular disease. Nobody's saying it's the best marker, but this is the opposite of what he's saying. I've read these guidelines. There's nothing in there about total cholesterol not associating, period. Maybe he saw something else and misunderstood it. Is there anything in the description that he links as a reference? Okay, 2 links to journals. That's good. American Heart Association journal. That's probably it. Let's click here. All right. Sweet. Wait, this is scientific advisory for dietary cholesterol. No way. No way. Don't tell me this guy's confused. Wow. Wow. Yep. Here's the passage he's referring to. Oh my God. Generally, no significant association with cardiovascular disease risk. But this document is the scientific This is the Science Advisory on dietary cholesterol. I think most people understand the difference, but just in case.
All right, so that sounds a little bit staged, but nevertheless, he's absolutely correct. I did make a mistake. The American Heart Association did not say that, but they did say that the dietary cholesterol is not associated with cardiovascular risk. However, if you take a look at this paper in 2018 entitled LDL Cholesterol Does Not Cause Cardiovascular Disease, a comprehensive review of the current literature under section 2, does high cholesterol cause atherosclerosis? And in summary, no association between total cholesterol and degree of atherosclerosis, that stuff that clogs up your arteries. So Gil's point is correct. American Heart Association did not say that, but another paper did say that. So both dietary cholesterol and blood level cholesterol is not associated with cardiovascular risk, more specifically risk for getting atherosclerosis. All right, let's move on.
Particle size no longer predicts risk. It's just like the ashtray analogy. And they add 2 more lines of evidence.
Okay, wait a second. Let's go back to this for a second. Saturated fats in cardiovascular health, current evidence and controversies. This is an editorial piece. It's not an actual study. It's someone talking about the data.
And they add 2 more lines of evidence. Statins, which have a well-established effect of lowering risk, preferentially reduce large LDL. And number 2, patients with familial hypercholesterolemia, which is a disease where people have very high cholesterol and very high risk of heart disease, they have mainly large LDLs, and they are at high risk, indicating that large LDLs are not benign.
Okay, the next point he brings up, which is rather a long explanation, I'm going to summarize it because it gets into a lot of additional things which are a bit complex. But basically, the point I was making was that you have 2 different size particles with LDL. You have small dense and you have large buoyant, okay? And I was making a point that the small dense were more pathological. They create more problems than the large buoyant particles. And so then he shows several references that it's not true. They're both damaging, especially if you look at the total concentration of LDLs. If that's high, that's going to be a bigger problem. But there was 2 additional studies that I want to show you right now that came a little bit later than the one he posted. This one was originally published in 15 February 2021. Small dense, low density lipoprotein, that would be the small dense LDL, cholesterol is the most atherogenic lipoprotein parameter in the prospective Framingham offspring study. In the conclusion, it says our data indicate that small dense LDL is the most atherogenic lipoprotein parameter. And then there's one more study I want to show you, 2017, small dense, low density lipoprotein, that's LDL, as biomarker for atherosclerotic diseases. So this is the conclusion. The results of the recent study demonstrate that LDL fractions, talking about the low dense versus the large buoyant, okay, the 2 different particle sizes, have different atherogenicity. That means ability to affect the arteries. With the small dense LDL being more atherogenic than the large LDL subfractions. Small dense LDL is characterized by the enhanced ability to penetrate the arterial wall that makes it a potent source of cholesterol for the development of atherosclerotic plaque. Importantly, longer circulation times of small dense LDL result in multiple atherogenic modifications of small dense LDL particles in plasma, that's your blood, further increasing its atherogenicity. Now, they just mentioned why the small dense LDL is more pathogenic, because it has the ability to penetrate the deeper walls, as well as having a longer circulation time. The longer that a small dense LDL is exposed to the arteries, okay, it's going to create more problems. And there was some additional data that there's more oxidation going on with the small dense LDL than the large buoyant. Okay, let's move to a different topic. One little thing that Dr. Gill kept bringing up was this word "we." he keeps saying, well, we did this or we're doing that. My first thought was, I thought you were an independent guy who just basically is putting out the message and doing videos on various topics. It's not on his YouTube channel. I had to do a little searching, and I suspect it's a group that he's a member of. And of course, I'm just guessing, but that's the only group that I could find. So Dr. Gill is a member or council member of an organization called True Health Initiative. So let's take a look at what this organization is. Plant-based diets for reversing disease and saving the planet. Okay, so this is a plant-based organization. All right, let's go down to the bottom and take a look at the purpose of this organization and what they do. Okay, changing policy, changing minds, improving lives. We are a global coalition of world-renowned experts fighting fake facts and combating false doubts about creating a world free of preventable diseases using the time-honored evidence-based fundamentals of lifestyle as medicine. Okay, so the whole mission is to fight fake facts and combat false doubts. Okay, all right. So that must be the organization that he's talking about when we're talking about we. If we scroll down, we see No Beef Week Challenge. Okay, so this is definitely a vegan or vegetarian type group supporting the benefits of plant-based. Let's take a look at their partners, the True Health Initiative partners. Okay, we have no beef. So I can see very clearly they're against beef. Now, if you look at how many videos that I have on meat and beef, there's a lot. I actually am pro-beef, right? I tell people to consume beef. Now I see why this fact-checking video was created. Dr. Gill also did one on Dr. Ekberg, who also has the same philosophy, because we're into a healthy version of the ketogenic diet. Okay, so now it's all making a lot more sense. So Dr. Gill, if you're watching, I just want to let you know I did participate in a study involving grass-fed beef and from farmers all over United States, and they submitted their beef into this study. And it was a metabolomic study looking at all these metabolites and comparing grass-fed to grain-fed beef, okay? And about 6 months after the study, the researcher called me up and said, "What are you doing?" I said, "What do you mean?" He says, "Take a look at this report. Look at this first graph, total phytochemicals. Phyto stands for plants. Interesting. So you can clearly see the difference between the beef that I submitted for this research project as far as the amount of phytochemicals, plant-based chemicals in the beef. And this was compared to other farmers who had grass-fed and compared to grain-fed. So this was the total phytochemicals. Okay, if we scroll down, we'll take a look at a very specific phytochemical called hippurate, which is the major polyphenol. These typically are antioxidant, anti-inflammatory, and higher levels are associated with improved gut microbial diversity and a lowered risk for metabolic syndrome in humans. Here's another one that was significantly higher, which is an anti-inflammatory metabolite. Here's another one, antioxidant, anti-inflammatory. And take a look at the fatty acid profile. We're looking at the omega-6 to omega-3 ratios. So a lower omega-6 to 3 ratio is typically considered beneficial. Lower levels means a higher abundance of omega-3 fatty acids. Here's another interesting finding, vitamin B3, quite a bit more than the other groups. Here's one that's a bit lower than the others, advanced glycation end products, which is a major negative marker for health. Here's another one, homocysteine, much lower than the other groups, which is a beneficial thing. And the reason I wanted to mention this is because so many times people lump in processed meat with grass-fed, grass-finished beef like they're the same thing. They're not. And of course, there's not a tremendous amount of research in the area of grass-fed, grass-finished, but that's coming using what's called metabolomic testing. So you could really see what's going on with these health markers. Because there is a difference in differentiating going to McDonald's versus getting a really healthy source of beef, which is filled with phytonutrients and a lot of other great things, including a lot of great bioavailable protein. So Dr. Gill, if you're watching, just want to let you know, there's a lot of positive things in beef that personally I feel very healthy when I consume it. But I can see that I'm a target for this organization for sure. All right, let's scroll down a little bit further on the True Health Initiative. We have Beyond Meat. All right, the truth about plant-based meats. Okay, I see. So this is definitely supporting plant-based meats and alternative meats. Okay. And if we do a search on Dr. Gill's site, you have quite a few videos about imitation meats or Beyond Impossible Burger, lab grown meat. I have no idea what your thoughts are. I didn't watch these videos, but you definitely talk about these products. Now, the president of this organization, Dr. David Katz, is definitely not a fan of keto or any other diet that restricts entire food groups, calling them unhealthy or unsustainable. He said that keto is just a false label for some kind of diet that presumably restricts added sugar and refined carbohydrates, which frankly any good diet does. Katz's low opinion on keto is echoed by many nutritional specialists across the country. Katz joined 24 other top names in the field to rank 35 popular weight loss programs for 2020, recently put up by the US News and World Report, which is a very credible news organization. I'm being very sarcastic. Here's another article, Toasting 2017 Goodbye with the Ketogenic Kool-Aid. This is by Dr. Katz as well. He said the historical case for ketogenesis, denying the body its customary fuel source, that glucose is in short supply, and instead it metabolizes fat preferentially and generates ketone bodies as fuel, resides in starvation. Rather predictably, starvation has profound effects on all aspects of metabolism. The body effectively turns to autodigestion to sustain itself during the protracted fast. Now, first of all, I can tell that what you're talking about is starvation. It's not even fasting. Your body might create autophagy, but it's not going to go after the muscles until you're actually starving, until you burn up your fat. I mean, this is the way our bodies were designed to store fat, to live during times of famine, and we didn't have food, so we would burn fat. So there's a way to do ketosis without even doing fasting and just cutting down your carbs. He goes on to say that the one known benefit of ketogenic diets is for the short-term control of otherwise intractable seizures, mostly in certain children. So why would that be a short-term thing if it helped him? And that's the only benefit that you know? Okay. You should go to my website. I have over 7,000 success stories, which you probably won't consider valid, but there's 7,000 people that are real testimonials of going on the ketogenic diet and looking at many other benefits. Here's another quote. There are, as noted, short-term studies of ketogenic diets showing the usual metabolic benefits attached to almost any diet. So basically, you just lump everything together. All right, whatever. But this next sentence is quite entertaining. But lest you think short-term improvements in these markers a good idea makes, consider these other interventions that do the same. A bout of cholera, a crack cocaine binge, the spread of cancer through one's body, or the advance of tuberculosis. My goodness. Many life-threatening diseases evoke autodigestion and cause weight, cholesterol, glucose, insulin, and blood pressure to fall. They are all emphatically ill-advised just the same. So he's comparing the ketogenic diet creating damage like you would if you smoke crack or had cancer or had TB. And the last thing I want to bring up, just one last quote. As I write this, the proposed guiding principles for healthy eating in Canada have just been released. They are eminently sensible, current, and evidence-based. So naturally, they are under immediate attack, as was the comparably sensible 2015 report of the Dietary Guideline Advisory Committee here in the US before its ink was dry. All right, so definitely he's talking about how there was some attack on this Dietary Guideline Advisory Committee. Well, if you take a look at this website called the usrighttoknow.org, nearly half of the Dietary Guidelines Advisory Committee have conflicts of interest. This is why it's attacked. So I'm not sure about Dr. Gill, but I definitely know Dr. Katz doesn't like keto and probably doesn't like my 980 keto videos, which very unfortunately, well, he'll probably like this. You can't even find them anymore. When you do a search on keto, all you see is the negative keto videos that come up. But of course, if you search for the plant-based ones, they're all really nice and positive. So my question for Gil and others who do like an anti-Dr. Berg videos is, what diet do you recommend? What should we be eating? And let's compare that versus just the ketogenic diet, because there's a lot of different ketogenic diet versions. The one I recommend is the healthy version. In fact, I don't know if Gil knows this, but I recommend 7 to 10 cups of vegetables every single day, which is a considerable amount of vegetables. I don't know if you knew that or not. But as I dug more into this True Health Initiative site, I found a link to this other site called eatforum.org. It's called the Eat Lancet Commission, the Planetary Health Diet. So as far as I know, this might be the diet that this group recommends. I don't know this for a fact, but it's definitely mostly plant-based, and they want to put this out to the entire planet. So this is what it looks like, okay? Here's the interesting thing about this diet. They're recommending 811 calories, be whole grains, okay? What about gluten? What about the phytates, which block zinc? And what about the fact that very, very few people have just whole grains? They have a combination of whole grains and refined grains. I mean, just take a look at the grocery store. They do recommend potatoes and cassava, fruits, 126 calories. But this is interesting. Beef. We can have 30 calories per day. That comes out to a half of an ounce per day. That's like a little tiny bite. But we can have 284 calories from legumes, okay, and 291 calories of nuts, and 354 calories of unsaturated oils. Would that be like soy oil, canola oil, cottonseed oil, corn oil? I couldn't find the specific unsaturated fats. And you're allowed added sugars, 120 calories. That's 7.5 teaspoons per day. Now, why is that on the list of a planetary health diet? Why do you even have to add sugars? What is healthy about those added sugars? I would love to know. Now, another thing about this planetary health diet is the strategic partners, okay? Strategic partners. Let's take a look who that would be. Well, we have Nestle. That's interesting. Nestle produces a lot of refined foods at the grocery store, don't they? Why are they involved in this planetary health diet? That's strange. Well, I did a little deeper dive on vegannews.com, and apparently Nestle is the first major food company to get behind lab-grown meat. Incredible. Dr. Gill, if you're watching, please tell us what we should be eating. And please educate us on what is damaging about what I'm recommending, and also what is so beneficial health-wise of what you're recommending. Now, because of the censoring and the suppressing of the algorithms on YouTube, it's becoming more difficult to find my content. And there's a lot of content that I cannot put on YouTube, unfortunately. So to make sure you have full access of all my information, go to drberg.com and subscribe to my newsletter by clicking the link down below in the description. I will see you on the other side.
林庆顺教授是加州大学旧金山分校 UCSF 医学院的教授，22年，现已退休，拥有40年的医学研究经验，及在世界知名医学期刊发表过近200篇研究论文。他在2023年5月4日发表《燕麦会越食越多病》，指出网络上流传的燕麦有害论是几位网红杜撰出来的，而其中一位就是所谓的百格医生。这位百格医生中文健康知识系列影片的主角其实并不是医生，而是 chiropractor 脊椎按摩师、整骨师。读者 Elliot 寄来一个影片 Dr. Eric Berg gets fact check Eric Berg 整蛊师被事实核查，指出 Eric Berg 引用的文献内容与言论之谬误，令人瞠目结舌的物质引用与误导宣称，以及分不清 LDL-C 和 LDL-P， 也分不清血清胆固醇和膳食胆固醇。以下是 Elliot 的后续留言。事实查核系列 by Gil Carvajal MD PhD 注，该频道之利益冲突声明拒绝一切品牌、商品、赞助、见证等盈利目的之合作。Michael Greger MD 纯素饮食。Eric Berg Chiro 生酮饮食 ，Paul Saladino MD 纯肉饮食 ，Stan Ekberg Chiro 生酮饮食 ，Cleanse Diet 排毒饮食。这几位仅是夸大不实程度太高以及影响力巨大的名字，这类极端饮食、流行饮食的网红医师们泛滥成灾。举例 Eric Berg DC 单是英语频道即有上千万粉丝订阅。 其他语种包括上百万粉丝的华语加总起来更是难以想象。Work 算是源头级的影响力，谣言产地各语言、各地区、各背景、各平台，尚有更多扩散推广他言论的网红。有人笑说无可奈何下，弃疗也是一个选择。Sitcom 个人小小的观察，最高订阅数与点击率的商学网红医师 by the Doctor of Business Administration 里 DC 整脊师民间认证 Andy 自然疗师民间认证为最大宗。随之是走中的 Board Certified MD 医师 Board Certified DO 医师 PhD 博士研究者 GP 全科医师 MPH 公卫研究者相对之下比较谨言慎行，也最网不红。网红营养师里也是相当混乱。营养疗师教练民间认证，营养师民间认证，运动营养师民间认证，合格注册运动营养师，部分国家合格注册膳食营养师，合格注册临床营养师，营养科学研究者整体概观，可信度大致上从低高。另中医师合格注册中医师，药剂生合格注册药剂师 ，Pharm 的药学研究者卡在医师、营养师之间，有良与无良的皆广泛存在。民众要在利用权威偏见 （authority bias） 的重视们里分清黑白，试读资讯确实不易。注解：民间认证，俗称花钱买文凭证书，里头不少训练仅仅是远端的函授，线上颁发入学许可、结业证书，连文凭都不是，更别说是学位。网红收入来源主要分成高自营卖商品、保健食品、保养品、营养品等线上服务、咨询、检测、课程、订阅、会员费、远距医疗等经营媒体帝国；中高业配、赞助、见证、代言、广告、电商导购、联盟行销等；中媒体、活动、节目出场费、形象制造商机主持费、影像出版品的权利金等；中科学研讨会出场费、封口费、喉舌费、撰稿费等游说制造舆论。低社群平台的流量广告费分成出版品版税、Patreon 群众小额捐款支持。部分科学家兼网红也有制造研究结果出版的顾问业务，贩售怀疑，制造科学与舆论间的混淆模糊地带。自营线下服务从高到低都有，高的有直销、非必要手术、高阶健检疗、医美、自费医疗陷阱、开精品超市卖鱼、无毒等；低的有增加点自家小诊所、健保门诊费、卖菜各种小生意。也有很多网不太红是做开心、使命、慈善、公益、回馈、教育、良心、信任感交朋友的非盈利。内文提及的 Eric Berg 的路线主要是来自于保健食品贩售、各国经销商，还有咨询服务、课程会员费与订阅费。百格医生的保健食品在华语世界里，无论是台港澳中兴码都有上架通路，跨境代购、一页式购物陷阱，甚至是区域经销商台湾总代理百格健康有限公司。统编29075726。P.S. 拿膳食胆固醇摄取的资料文献来解释血清胆固醇含量，忍住不笑有点难捏，1000多万名粉丝都没有点进去稍稍瞄一眼嘛。